Okay, can everyone hear me? Please use the chat box. Send me a message whether you can hear me or not. Send me a few messages, right? Okay, how's now? Everyone can hear, right? Okay, write down electricity. So we'll start. Today I'll be discussing electricity, right? So this is one of the most important unit. You will definitely get a question about at least 5 MCQ questions, right? So you can get 5 marks there. Then definitely you will get a structured essay question from this. So another 5 marks. Then definitely there are going to be a essay question. So only from this unit you can get at least you can get 17.5 marks, right? Only from this unit. So let's revise this one on electricity. Okay, take down the topic electricity. Okay, first, when it comes to electricity, you need to know that what is electric current, what is potential difference, and uh, what is potential difference and what is electric resistance, right? So those ones you need to know first. First, I'll talk about electric current. So before knowing that, you need to know that what is it muted? Everyone can hear, right? Yeah, everyone can hear. Okay, okay. Right. The YouTube live stream, I don't know whether the YouTube is. It is not muted on YouTube, right? So, someone send me a message on the YouTube. Okay, right. Okay, so under electricity, what you will learn is moving charges. So in electrostatics, you learn about charges at rest, but under electricity, you will learn charges that are moving. So here, this is similar to hydrostatics and hydrodynamics, somewhat similar, right? So we will have the same model. So before talking about electricity, we need to know about the mechanism, how the electric current is formed, right? So as I'm writing this, you can take notes, right? Right. So let's take a cross section of a conductor. Cross section of a conductor. So you know that. So it is consisted of atoms, right? It is consisted of atoms. There's a nucleus. Then there are inner shells and outer shells. So outer shells has free electrons, right? So for the electricity, only free electrons participates to form the current, right? Electric current is formed only using free electrons. So you know, in a metallic lattice, only free electrons can move, right? Okay, so they are free to move. So when you provide a potential difference, let's say V using a cell, or it can be any electric source, power source. So what happens is, I'm only marking free electrons here. So these electrons are submitted to a acceleration, right? So they starts moving. So this is the positive side of the cell, this is negative side. So this cell causes a positive potential here and a negative potential here. So towards the positive potential, these electrons are negatively charged, right? So towards the positive, these electrons moves. It starts moving, right? So these are electrons. So by definition, electric current is defined as a stream of positive charges. So flowing of electron to this side is equivalent to a positive charge moving to the other side. So that stream of positive charges is what we call electric current, right? So when the electrons move to this side, electron flow move to this side, electric current, we say that that moves to the opposite side. So this is an equal amount of charge, but we can consider electron moving to this side. We can say a positive charge is moved, it is equivalent to a positive charge moving to the other side, right? It is moving to the other side. Okay, just take down these notes as I am writing on the board. So that is how the electric current flows. Okay, take down these. Right. Then electric current, we normally define that as capital I, electric current. So what's the definition of electric current? It is rate of flow of charge, right? So if you take a cross section, this cross section you can take anywhere, like here or here. So when you take a cross section along the circuit, and if you count the amount of charge flowing through that cross section within a given time, you can measure the electric current. Let's say that charge is capital Q. That charge is capital Q, and you divide that by the time, then you get electric current, right? Then the another thing is, you know that electric charge, this is electric charge, is consisted of what? Electric charge is consisted of electrons, right? It is consisted of electrons. So you can say, let's say capital N number of electrons. So one charge of one electron is simple E. So you know that is equal to this number, right? Coulomb. Then number of electrons that passes through this cross section. Then this is the total amount of charge that went through this cross section. So if you want, you can substitute capital NE instead of Q and divide by time. So you get a rate of charge flow, which is defined as the electric current. So when you think about this equation, this is what? Coulomb divided by seconds, right? Coulomb divided by seconds. So we can say coulombs per second. So 1 coulombs per second is defined as a 1 ampere. Okay. So if 1 coulomb goes through this cross section within a 1 second, we say that electric current through the conductor is 1 ampere, right? So these equations are important, right? Take this down. So I'll do an example, right? Let's say, just take this down. If I equals 3.2 milliamperes, if I equals 3.2 milliamperes, find number of electrons through the cross section for 5 seconds. For 5 seconds. Use one of these equations. Then you need to find the number of electrons that went through the cross section for 5 seconds. Right? Someone tell me the answer. Just solve this one. You need to find the number of free electrons went through the cross section within 5 seconds. This is an easy question. Just quickly tell me the answer. Okay, what's the answer? So what they're asking is capital N, right? 10 to the power 16. Yeah, it is 10 to the power 17, right? So 10 to the power 17 number of electrons go through this cross section within a 5 seconds in order to create this much of a electric current. Milliampere means 10 to the power minus 3. Okay, yeah, correct. 10 to the power 17, that is the number of electrons. Okay, then write the topic mean drift velocity. Mean drift velocity. Write the topic mean drift velocity. We define that as VD, right? Mean drift velocity, VD. Right. So when we think about the electrons inside this, they don't perfectly move like this, right? Inside this, it is a chaotic motion, right? Like it moves like this. Usually the speed of an electron is around 10 to the power 6 meters per second, right? But if we only consider the forward motion of electrons, there's a chaotic motion, but it's still a bit, it is moving forward, right? If you only think about the forward motion of the electron, then that is accounted for the drift velocity. Usually drift velocity values are around 1 millimeters per second, right? Around 1 per second, it moves only like 1 millimeter here. But the actual speed is 10 to the power 6. Though they move chaotically here, it only has a forward motion of about 1 millimeters. So that is what we call, if you only count that, we call that drift velocity, right? Drift velocity. Then we can derive an equation for electric current using the drift velocity. So it is like this. So if you multiply drift velocity by cross section, what do you get? Cubic meters per second. Cubic meters per second. Then there is something called capital N, right? Or we can call simple N. Simple N is electron density. If you want, you can take this down. Electron density. Electron density is number of electrons per unit volume. So the unit of this is number of electrons per unit volume. Per unit volumes means per cubic. So if you multiply these two, you get per second. Per second number of electrons that goes through here. Then you can multiply this by the charge of an electron. Then what do you get? You get that coulombs, right? So the final unit is coulombs per second, right? So you need to remember this equation as 1A or something like that, right? So this is the equation in terms of drift velocity. Drift velocity, cross section of the conductor, electron density times charge of an electron, right? So like that you can remember this equation, I equals VA dNE, right? Take this down, right, as I'm explaining. Yeah, you can just take the notes, right? It won't be in vain. Just takes notes, right? So ID equals VANE. Right? Okay, then there's another quantity that you need to know that is called J. We call this current density. So the current density is defined as electric current divided by the cross section of the conductor. So you know that there's a cross sectional area here. When you divide that, you get the current density. So what is the unit of this? Ampere divided by meter squared. So the unit of current density, you can take these words, right, if you don't know current density. Amperes per square meter. So that is how we measure the current density, right? This unit also is important. Then if you substitute this I here, you can get another equation. If you substitute I here, what do you get? VANE divided by A. So for current density, we have another equation, AA cancels off VNE. So this is for the current density, right? Right. I'll give you another example, right? Because these are the basics, I need you to do these examples as well, right? So they have given cross-sectional area as 1 square millimeter, right? Current is 3.2 amperes. Current is 3.2 amperes. And they have given VD. VD means drift velocity. It is given as 2 millimeters per second. So what you have to find is simple N. Simple N means free electron density. Simple N and capital J. Do this one. So these are the data given. You need to find free electron density and current density. Free electron density and current density, right? Just send me the answer. Send me the answer, right? So what they ask is free electron density and current density. These are the data given. 1 square millimeter, right? You just have to substitute using the equations. You need to convert this into meters, and this is 2 millimeters per second, right? Drift velocity is 2 millimeters per second. So what is the value? Someone sent me, right? You just have to substitute the values in the equation. Yeah, electron density is 10 to the power 28 and current density is 3.2. Okay, let's simplify this. So first you need to find simple n, right? That is electron density. So where did we have electron density? So I equals VA NE. So electric charge current is 3.2. Drift velocity is 2 millimeters per second, so 10 to the power minus 3. Cross-sectional area is 1 millimeter, meaning 10 to the power minus 3 squared, so minus 6. Then simple n, charge of an electron is 1.6, 10 to the power minus 19. Then simple n. Got it? Then simple n. So you just have to simplify this. 1.6 means 2 here, then cancel this one. Then you get 1 equals 10 to the power minus 9, 9, 28, minus 28, 10. So n is equal to 10 to the power 28. So the unit is per cubic meter, right? Per cubic meter, there's 20 to the power 28 electrons. Yeah. So that is correct. Then what they ask is current density. This is electron density, this is current density. So what's the equation? I divided by A. So electric current is 3.2 amperes. This is 1 millimeter. If you want, you can put this in millimeters as well, right? So it should be 3.2 amperes per square millimeter. Or else you can put this in meters or millimeters, it doesn't matter. Yeah, correct. I need everyone to send me answers, right? At least you need to be interactive there. Okay, so that is all about electric current, right? So that is all about electric current. Then we need to think about electric potential energy, potential difference and electric resistance, right? Then write the topic Ohm's law. Write down Ohm's law. Remember the Ohm's law? What is the Ohm's law? So Ohm's law basically says when you have a resistor, so this is a resistor, right? Electric resistor. And when you provide a potential difference, this potential difference is proportional to the electric current through the resistor. These should be constant, right? Constant temperature. If the temperature is constant, potential difference provided to a resistor is proportional to the electric current through that resistor. Electric current through that resistor. So that is Ohm's law, right? Then what this means is V is equal to Ki. V is equal to Ki. So this K is found to be electric resistance, right? Then we get this famous equation V equals IR. V equals IR, right? So this equation is like F equals MA, right? Throughout electricity, you will need to use this one. V means potential difference, right? So this is a difference actually. So we can say delta V is equal to I times electric resistance. But you can apply this equation given that temperature is constant. Given that temperature is constant, you can apply this equation, right? Right. So usually, when you send the current through a resistor, temperature increases. So that is the practical case, right? But there is a hypothetical resistors which are called ohmic resistors, right? Ohmic resistors. Or we call those linear resistors. The specialty about these resistors is even though there's a current, current flows through them, the resistance does not change. So those are called linear resistors. So if you draw a IV graph for a linear resistor, capital R remains constant. So if you think about V equals IR, then here I goes for the Y axis, right? So we get I equals 1 over R times V. So this is Y, this is X, and this becomes M, gradient. So gradient is equal to 1 over R, right? 1 over R, since R does not change, the graph will be Y equals MX graph, and the gradient is constant, right? Gradient is constant. So that's why these kind of resistors, we call them linear resistors. So when we are solving problems, those resistors are mostly linear resistors, right? Linear resistors, but that is a hypothetical case, right? Practically, you cannot have linear resistors. But for our convenience, we assume that those resistors to be linear resistors. Otherwise, we cannot use this Ohm's law, right? Okay. Another thing is, let's say you have like a practical case, you get like a tungsten filament, right? If you have a bulb, if you get a bulb and it has a tungsten filament, you know that as the electric current goes through that filament, its temperature increases, right? For a practical case. So for a practical case, this is the IV graph. So what happens there? Let's say tungsten, right? Tungsten filament. So what happens is, as the temperature increases, usually resistance also increases for a metal. Tungsten is a metal, so the gradient decreases, right? 1 over R, gradient decreases. So the graph would be like this. It would be like this, gradient decreases. So these are non-linear conductors, right? These are linear resistors and these are non-linear resistors. But when you are solving problems, what you get is linear resistors, right? What you get is linear resistors. Okay, take this down. So I'm explaining, you can take this down, right? I cannot give you. Right. So let's apply V equals IR. Let's apply V equals IR. Example 1, first example. So this is a part of a circuit, right? Part of a circuit. Draw this with me. So here you have A, and resistance is 10 ohm, 20 ohm,
මෙන්න ආවම අපිට පේන්නේ ඇත්තටම සර්ව තියෙනකොට
then 70 ohm, right? Here you have A, point A, and here B. And this place, it is earth. Earth means electric potential here is 0 volt. So that is what earth means, right? And they say there is an electric current here that is 3 amperes. So what you need to find is VA, potential at A and potential at B, right? So if you can understand, try this one. You need to find potential at A and potential at B. This is a part of a circuit, right? Through the branch, there's 3 ampere, and these are the resistance values given, resistor values given. Here the potential is 0 volts. So what you need to find is potential at A and potential at B. So you need to understand these concepts first. right? So this is the most fundamental thing. This is how you analyze a circuit. You must understand this one first, right? So you need to be able to find the electric potential at any place in a circuit, right? So without understanding this, it is not possible to learn electricity after that, right? So you need to know how to find this first. Okay, so this is the procedure, right? Now listen. So by applying V equals IR, this V means potential difference, right? You can find the potential difference across any resistor using V equals IR. So if this is a one branch, there's no leak in current here, right? Current does not go through towards the earth through. So along this branch, only current is 3 amperes. So the current through 10 ohm is also 3 amperes. Here 3 amperes, here 3 amperes. This is a one branch, right? So that branch cannot have different currents. It has this only 3 ampere of current, right? So what's the current here? 3 ampere, and the resistance is 10 ohm. So according to V equals IR, current is 3, resistance is 10. 3 times 10. So here we have a potential difference of 30 volts. Potential difference, right? You have to understand the difference between potential and potential difference. A point has a potential, electric potential. So the resistor is between 2 points. Between 2 points, it is a potential difference. So you can find the potential difference using IR. So here you have a 30 volt of potential difference. Here how much? 3 times 20, 60 volt. Here 3 times 70, how much? 210 volts. So when you get a question like this, first step is find the potential differences. Then we can find the potentials, right? The another rule here is electric current always goes from a higher potential to a lower potential. That is the another rule, right? Electric current always goes from a higher potential. Higher potential means positive potential. Goes to a negative potential. This is higher to a lower. This is a rule, right? Electric current through a resistor always goes through a higher potential to a lower potential. There's a resistor, right? So we know that potential here is 0 volts. Here the potential is 0 volts and the difference is 30 volts. In order to have a 30 volts of difference, what should be the potential here? If the potential here is 0, here the potential can be minus 30 volts or plus 30 volts, right? Potential at A can be minus 30 volts or plus 30 volts, right? So how do we figure out whether it is minus 30 or plus 30? Electric current goes from a higher potential to a lower potential. So it cannot be minus 30, right? It should be plus 30. It should be plus 30. From a plus 30 to a 0 volt. Now we found the potential here, plus 30. Then you need to find the potential at B. Then you need to find the potential at B. So here the potential is 0 volts. Towards the direction of current, electric potential decreases, right? Drops. This has to have a potential, less potential than here. So the difference is 60 volts. So if this is 0, it should be minus 60 volt here. it should be minus 60 volt here, right? Then if you go to this side, then the current flows to here, to the lower potential. So it should be less 210 than minus 60 volts. So it should be minus 60 minus 210 volts. What is that? 270 volt. Here the potential should be 270 volts. Minus, right? Okay, you can take this, and if you don't understand, again do this at home, right? As homework. If you have any problem, let me know. You must understand this, right? If you don't understand, after that it will be really difficult, right? If you have problem, let me know. Right? Okay, second example, take this down with, take down this. There's a resistor 30 ohm, point B, and 10 ohm, this is point A, and 20 ohm, point C, and it is earth here, right? Earth means 0 volt. Potential here is 0, but there is no current flow to the earth, right? Just remember that. The only meaning of earthing is the potential there is, should be 0. That is the meaning there. So they have given, if VA equals 10 volts, VB equals 15 volt, find VC. So A and B is given, potentials at A and B given. So what they ask is potential at C. You need to find the potential at C. Someone said, let me know the answer. You need to find the potential at C. You need to practice this, right? You need to practice this. So you should be able to find the potential at in circuits. So if you are learning for the first time this, it might be somewhat difficult, right? But just listen there, you will get something there, right? I know this takes some time if you are learning this for the first time, right? But minus 30. Okay, let's see. Now listen, right? Okay, now listen. So what they say is potential at A is 10 volts. They say that potential at B is 15 volts. Potential at A is 10, B is 15. Okay, and here 0 volts. So what's the potential difference in this branch? 10, here 0. 10 minus 0. Potential difference is 10 volts. 10 minus 0, 10 volts. Got it? So if you know the potential difference and if you know the resistance, just apply V equals IR to this branch. What's the potential difference? 10. Current I, resistance 10. So I is equal to 1 ampere. So the current through here is 1 ampere. This is the higher potential, this is lower potential. So the current flows to this side. Okay. Similarly, you can find the current in this branch. So what's the here potential is 15, here potential 0. So 15 minus 0, 15 volts here. So just apply V equals IR. V is 15, I, then R is 30. So what do you get? I is equal to 15 divided by 30, which is 0.5 amperes. So there's the current 0.5 amperes. In this branch, 0.5 amperes. Here, 1 ampere. So those currents adds up. 1 ampere plus 0.5 means in this branch, there should be a 1.5 amperes. Okay. Then for this branch, it is 1.5 times 20. So for the potential difference, if you apply V equals IR, potential difference is 30 volts. Okay. So now we know the potential difference across this resistor. So the current flows to this side, right? Current flows to this side. So here 0. So the potential here should be minus 30 volt. It is not plus 30 volt, right? So in order to have a 30 volts of potential difference, if the potential here is 0, here the potential should be minus 30 volts. Okay, it can be plus 30 volts or minus 30 volts. But here the potential should be less than 0. So this is what? This is minus 30 volts, right? This is minus 30 volts, not plus 30 volts. Understand? If you have problems, so you must understand if you these, right? How to find the potential and potential differences. Okay, third example. That's why I'm doing so many examples here, right? Okay, just draw this with me. So A is here. Here you have 10 ohm, then 20 ohm, then 30 ohm. And here the point C, and they say electric current in this branch is 2 amperes. So the question, first part is if VA equals 200 volts, find VB and VC. So this is the first part. If VA is equal to 200 volts, find VB and VC. Then the second part is if VB equals minus 20 volts, VB equals minus 20 volts, find, this is another question, right? Find VA and VC. Here the VB is equal to minus 20 volt, find VA and VC. Okay, try these, first one and second one. Those are two questions, right? So the first step is just apply V equals IR to each resistors and find the potential difference. So if you know the potential differences, then you can simply find the potentials. Another rule you have to consider is electric current always goes from a higher potential to a lower potential. By considering those two rules, you can find the potential at in any circuit, right? The thing is, you need to understand what is the potential and what is the potential difference. Just take this down first. Okay, so what is the first step? You need to find potential differences across each resistor. That is the first step. So what's the current here? It is 2 amperes, right? One branch, so the current 2 amperes. So V equals IR. 2 times R is 10. So potential difference is 20 volts. Here the potential difference. Current is 2 amperes. Resistor 20. So the 40 volts. Here current is 2 amperes. Then 60 volts. So these are the potential differences across each resistor. That's the first step. So everyone should be able to do that, right? Just apply V equals IR. Okay, let's see. Okay. So this one you should be able, you should be able to do, right? It is a potential so first step, find the potential differences. Then you need to find potentials. Okay, how do you find that? They say potential at A is 200 volts. Here the potential is 200 volts and the difference is 20 volts. What does it mean? At C, potential should be 220 volts or 180 volts. But the current flows to this side. So the potential here should be 20 volts less than potential here. Because potential has to decrease across the resistor towards the direction of the current. So what's the value of potential here? VC is 180 volts, right? 20 volts less. So there's the potential difference. Then let's find the potential here. Here 180 volts, then 40 volts less to the direction of current, right? 40 volts less means 140 volts here. 180 minus 40. Then here 60 volts less. Why is it less? Because that is the direction of the current, right? To the direction of current, I mean current always flows from higher potential to a lower potential. That is why less. So 60 volts less means 140 minus 60. How much? 80 volts. Yeah. So you get 180 and 80. Yeah, pressed on. Then the second question, right? In the second question, so it is a different question, right? Same circuit but different because they have given different values for the potential VB. Here, according to this one, VB is 80, right? Okay, according to this one, VB is 80, VC is 180 volts. Okay, just take it down. I think everyone have marked the potentials, right? Then I'm going to erase these potential values, right? In the next question, they say, if you want, you can draw this in a separate image. VB is minus 20 volts. They say VB is minus 20 volt. If VB is minus 20 volt, you need to find VA and VC, right? So let's move from here to here, right? So the current goes from a higher potential to a lower potential. So the potential here should be 60 volt more at this point, right? So minus 20 plus 60. How much is it? Plus 40. Minus 20 plus 60. Right? Plus 40. Then plus 40. It is 40 volts more here. So it should be 80 volts. 40 plus 40. 80. Here 20 volts more. So what do you get? 100 volts. So for A it is 100. For C it is 80 volts. Yeah, correct. 100 volts and 80 volts. So that is for the second part. So this thing you need to you must understand these things, right? Without that it is not possible to learn electricity, right? So if you didn't understand, just try this again. Right, then draw this circuit. Draw this circuit. This is just wires, right? This doesn't have a resistor, just wires. So 10 ampere comes like this, 1 ampere comes like this, and there's I. 2 ampere goes outwards. So you need to find I. Find I, right? So these are like water flows, right? Water flows, water streams. So if a current goes like this, then part of that goes here, part of that goes here. So according to that, you need to find this capital I. So what's the value? Right. Okay. This one you must understand this one, right? This is an easy one. So 10 ohms goes like this. 1 ampere goes like this. Okay. So into the circuit. So it is 11 amperes going to the circuit. So 11 amperes should leave the circuit as well, right? There's this current given, right? 6 amperes is given there. Okay, if 10, so from this question you will understand how the electric current flows. Okay, so 10 amperes goes like this. Then if there's a 6 ampere in this branch, here it should be 4 amperes going like this, right? Okay, then 4 amperes here, 1 amperes here, then these two adds up. In this branch, it should be 5 amperes. Understood? So in a certain branch, there is only one current moving to a one side, right? Moving to a one side. Okay. So there is 6 ampere, then 2 ampere goes out. Then what should be the current here? There's no any other path for the 6 ampere to go, right? If 2 amperes goes to this side, then there's a 4 ampere remaining. So 4 ampere should be here. Then 4 amperes in this branch, another branch 5 amperes, they adds up. And finally, current is going to be 9 amperes. Yeah, correct. It should be 9 amperes. So this one you must understand, right? This is like general knowledge, right? These are like water flows, right? If there's a 2 streams of water, then adds up these waters, then it goes through one canal, right? Just take that down. Then there's another circuit. Just take this down. 2 amperes, 2 amperes. There's I. 1.3 amperes. 2 amperes. So you need to find I. Okay, let's find that. Capital I. These are common knowledge, right? Like you just need to be analytical. You need to find capital I here. It's 1.3 amperes. These are like just puzzles, right? So others, others also, please send the answer. You have to try these, right? By on your own. I'm just explaining everything is not going to work, right? You need to try these by yourself. Okay. So this is how it is going to be. 2 amperes, 2 amperes. So in this branch, it is 4 amperes, right? 4 amperes. That's the first thing. Then you can see 1.3 leaves and 2 amperes leaves. So in this branch, it should be what? 3.3. Got it? 3.3 goes like this. Then the 1.3 here, 2 amperes here. Right? Then consider this one. 4 amperes goes in this branch. Then 3.3 goes in this branch. So what should be the current here? If 4 out of 4 amperes, there's a 3.3 amperes in this branch. The remaining one amount is 0.7, right? 0.7 amperes. Understood? right? So up to now we discussed how to find the potentials and electric currents in like a part of a circuit, right? Then let's consider closed circuit, closed circuits. Just draw this with me. Draw this with me. There is 9 ohm here, 3 ohm here. Current I comes like this, and there's a cell. These uh, difference is 4.5 volts, right? So you need to find I, then I1, then I2. So what they ask is find I. First you need to find I1, I2, then you need to find I. Find this I1, I2 and I. You just have to apply V equals IR, right? So that is similar like F equals MA, right? You need to apply that everywhere. You need to find in that order, right? First I1, then I2, last I. Okay, someone send me the answer. This is not difficult. Right. So I'll explain. Right. So there's this cell 4.5 volts. So you can see these are like I mean these wires does not have resistor, right? So the potential difference across these 2 points is 4.5 volts. 4.5 volts. Do you understand that? If 4.5 volts is the potential difference here, here as well it should be 4.5 volts. So both of these resistors are under a potential difference 4.5 volts. Do you understand that? Right? So what's the potential difference here? 4.5 volts. Here as well 4.5 volts. Okay. So here you know the potential difference 4.5 volts. Then what should be the I? So I is equal to V over R, right? V equals IR. 4.5 volts divided by 9 ohm. So what do you get? 0.5 amperes. So I1 is 0.5 amperes. Here potential difference is 4.5 volts. So that is I2. That also is under 4.5 volts. Then divide that by 3 ohm. You get 1.5 amperes. So in this branch it is 0.5 amperes. Here it is 1.5 amperes. So this current has divided into 1.5 amperes and 0.5 amperes. So the I should be what? 0.5 plus 1.5. So it should be 2 amperes. Right? Yeah. Understood? So the answer should be 0.5, 1.5 and 2 amperes. Then draw this circuit. With me, draw that. 2 ohm, 12 ohm, 4 ohm, 6 volt. There's a battery, 6 volt. Current here is given as 1.2 amperes. Here in this branch 1.2 amperes. There's potential difference V1 and here potential difference V2. There's a I1, there's a I2. Right? So you need to find these in order, right? First you need to find V1, then V2, then I1, I2, finally capital I. So you need to find these in order, like the in order, right? These are not that, I mean, once you get used to these are not difficult, but if you are learning this for the first time, it might look complicated, but these are not complicated ones, right? First you can find V1, right? If you find these in this order, it is going to be easy, right? That's why there's order there. So you can easily find V1, right? You can easily find V1. How do you find that? You know the electric current here through 2 ohm, it is 1.2 amperes. So what should be V1? V equals IR. Current is 1.2 and resistance is 2. So it is 2.4 volts. So across this resistor, it is 2.4 volts. Yeah. Okay. Then do you have a like here V1, right? Then here potential difference is V2. V2 is for both resistors, it is V2, right? So do you understand like V1 plus V2 is the potential difference here, and it is should be equal to 6 volt. Do you understand that? V1 plus V2 is the potential difference across these 2 points. Then that is should be equal to the 6 volt. 6 volt equal V1 plus V2. V1 you already found as 2.4. Then you need to find V2. So what is the value? 3.6, right? When you subtract this, so you get 3.6 volts for V2. That is the potential difference there. So if you know V1 and V2 values, then you can easily find I1 and I2 values, right? I2 and I1 values. So what is I1? I equals V over R. Here the potential difference, these two resistors are parallel resistors, right? So both resistors have the same potential, right? So V2, we found that 3.6 divided by that resistance, 12 ohm. So you get 0.3 amperes. That is I1. Then I2. So you have here V2 is 3.6. 3.6 divided by 4 ohm. So that is I2. Potential difference is 3.6 here. Divide that by 4 ohm. So you get 0.9 amperes. Got it? If you have any problem, let me know, right? Okay, then draw this circuit with me. 4 ohm. So you need to find I1, I2, I3 and I. So you need to find this I1 first, I2, I3, then I. All you have to do is just apply V equals IR, right? Okay, so what is I1? I1 is what? So here you need to understand this, right? Difference is 3 volts. Here also 3 volts, right? Here also 3 volts. Here also it should be 3 volts. Understand? 3 volt, 3 volt, 3 volt. Because these branches are parallel to 3 volt, right? Okay, so I1 potential difference is 3 volts. So what is I1? VOR. Difference is 3 volt. Resistance is 4 ohm. So it is 0.75 amperes. Got it? 0.75 amperes. Then you need to find I2. I2 also VOR. But I2 has two resistors. This 3 volt is applied for both, right? So the total resistance is 12 ohm, right? 4 plus 8. Potential difference is 3 volt. Resistance is 12 ohm. So it is 1 over 4, 0.25 amperes. That is I2. Then I3. Potential difference is 3 volts. Divided by resistance 6 ohm. So that is going to be 0.5 amperes. So you found I1, I2 and I3. So here you need to understand this I is divided into these I1, I2 and I3 values. So the sum of these electric current needs to be I, right? So I is what? 0.75, 0.25, 0.5. So 1.5 amperes. Understood? Yeah, correct. So it should be 1.5 amperes. So these simple circuits you need to be able to solve, right, using only V equals IR. So that is the first skill you need to learn, right? These are simple circuits. Okay. Then draw this one with me. 1 ohm, 5 ohm, 4 ohm, there's 2.4 volts. So here you have I1, then I2. Here the potential difference is V1, here it is V2, and across here it is V3. So what you have to do is you need to find V3 in this order, right? You need to find in this order V3, I2, I1, V1 and V2. You need to find the values in this order. So the next lesson after this is electronics, right? Without understanding this, it is not possible to learn electronics, right? So you need to understand these. Okay, so this V3, you can directly say the value, right? See that? 2.4. It is V3, right? Across 4 ohm, it is just 2.4, right? It is parallel to 2.4. Do you understand that? So V3 is directly 2.4 volts. Okay, you didn't meet any resistors here, so it should be directly 2.4 volts across 4 ohm. Then you can find I2. What is I2? I2 is V divided by R, right? Potential difference, we know that is 2.4 volts. 2.4 volts. Then the resistance is 4 ohm. Resistance is 4 ohm. Potential difference is 2.4. So what do you get? 0.6 amperes. That is I2. Understood? Then you need to find I1. This I1. But for I1, there are two resistors in series, 1 ohm and 5 ohm. Right? So there's 2.4. So the total resistance is 6 ohm here. 6 ohm. Potential difference is 2.4 divided by 6 ohm. 1 plus 5. So what do you get? 0.4 amperes. So I1 is 0.4 amperes, I2 is 0.6 amperes. Okay. Okay, so if you know those, you can find V1 and V2. In order to find V1, which is the potential difference across 1 ohm, right? So how do you find that? I1 is equal to, where is I1? We found I1, right? 0.4. 0.4 times 1. So it is 0.4 volts. 0.4 volts is potential difference here. Just apply V equals IR to this resistor. Then you need to find V2. To find that, apply V equals IR to this resistor. So it is I1 is 0.4 times resistance is 5. So it is 20 volts, which is 2 amperes. I mean 2 amperes, sorry, 2 volts, right? Get it? Here 2 volts, here 0.4 volts. So 2 plus 0.4, 2.4, right? Here also 2.4, here also 2.4. Right? So that is how you analyze a circuit. So you need to develop this skill, right? To quickly do this, right? So any simple circuit you need to just analyze using V equals IR and understanding potentials, electric potentials. So that is the first thing you need to do, right? Right. Take it down. right? So after this, we need to learn about resistors, electric resistances in depth, right? So up to now we discussed how those resistors, so all these resistors are like linear resistors, right? But after this, we need to understand how that resistance is formed. So when you take a resistor, the resistance value depends on the temperature of that resistor. And other one is dimensions of the resistor, right? So for a metal, if you think about a metal, when you increase the temperature, resistance of the metal increases, right? Then if you think about a semiconductor, resistance decreases. For an insulator also, resistance slightly decreases. Then you need to think about dimensions of a resistor. Dimensions means cross-sectional area of the resistor and the length of the resistor. If the length increases, resistance increases. If cross-section increases, resistance decreases, right? So first, let's consider about how the resistors behave with temperature, right? So for that, we need to define this quantity, which depends only on the type of material, which we call temperature coefficient of resistance. If you want, you can write these ones. So what is this? Temperature coefficient of resistance, alpha. Temperature coefficient of resistance, alpha. So I'll directly write this equation. Resistance of a given temperature is equal to R naught. R naught means resistance of the resistor at 0 centigrade times 1 plus alpha theta. This is the temperature value in centigrades, right? When you're solving a problem using this, you need to consider this. R naught should be always resistance at 0 centigrade. Resistance at 0 centigrade, right? Then alpha is what we call temperature coefficient of resistance, that is alpha. Theta is temperature value in centigrades, that is theta. Got it? So further I can explain this. So let's say at 20 centigrades, right? Just take down this with me, right, as I'm explaining. So at 20 centigrade, let's say resistance is 1.5 ohm, right? If at 20 centigrade resistance is 1.5 ohm and at 80 centigrades resistance is 1.6 ohm. So do you understand that resistance has increased? So what you have to do is find alpha. Do that. You can try that. So these values given, right? 20 centigrades, 1.5 ohm. At 80 centigrades, 1.6 ohm. Those values are given. Okay. So if you substitute this using this equation at 20 centigrade, for this one you can put 1.5. Okay. But R naught is not given. At 0 centigrade it is not given, right? So you need to substitute as R naught. You don't have value there. You cannot substitute this one, right? Resistance at 20 only is given. So 20, it is 1.5. R naught is not given. So 1 plus alpha. Theta is what? So this value is at 20 centigrades. So you substitute 20, right? Not 60. You substitute 20. So you have one equation. Then you have at 80 centigrades. At 80 centigrade, resistance is 1.6. Then there's R naught 1 plus alpha. Temperature is 80. This is not a difference that you are substituting, right? This is just the temperature value in centigrades. This is unlike linear expansion. Okay, so this is second one. Then you can simply divide 1 by 2 and get rid of R naught. Then only unknown will be alpha. Then you need to find alpha. So 1 plus alpha 20 divided by 1 plus alpha 80. Okay. Then cross multiply. Then I'm not going to do the simplification. You can do the simplification later, right? So this is how you substitute those. Right. So when you think about this equation, alpha temperature coefficient of resistance is positive for metals or conductors, right? When you think about conductors, mostly it is metal, right? This alpha is a positive value. So according to this equation, if alpha is a positive value, when temperature increases, resistance increases, right? So if you draw that in a graph, the graph would be like this, right? So the gradient here, can you see it is R naught alpha. Alpha is a positive gradient, right? So this is for conductors. Then you have semiconductors. Take notes, right? For semiconductors, when temperature increases, resistance decreases. You need to remember that. The reasons we'll discuss when we do electronics, right? So when temperature increases, resistance decreases. This is for semiconductors. So we say that alpha is a negative value. Coefficient is negative. When temperature increases, resistance decreases. That is for semiconductors. Then you have insulators. So for insulators, when temperature increases, resistance slightly drops, right? Resistance slightly drops. So alpha is almost zero there for an insulator. This one you need to remember, right? For an insulator, it slightly drops when the temperature increases. You can take those down. So here alpha is almost zero, right? Approximately, but it is all for an insulator. For a semiconductor, it is negative. When you increase the temperature, resistance of a semiconductor decreases. Semiconductors means like silicon, germanium, those are semiconductors. Here it is copper, iron, like that, right? So those are conductors. So this is how the resistance behaves with temperature, right? Then you need to think about how the resistance behaves with the dimensions of the resistor. Let's see that. Just takes notes, right, as I'm explaining. Right. So if we take a conductor, or let's say this is like a rod, like a wire or something. So the current flows through the conductor, right? Flows through the conductor. Then the resistance of this conductor depends on length and the cross section. So those are the dimensions of the conductor, right? So this is cross section capital A and length simple L. So you need to understand that when capital A increases, electric current can easily flow. So there's less resistance. Then if the length increases, it is difficult to flow. Electric current finds it difficult to flow, right? So according to that, you have this equation. R equals rho L divided by A. So you can understand when length increases, R increases. If A increases, R decreases because it is at the denominator. Got it? Then there is this rho. What do we call that? We call this resistivity. So this resistivity is a constant only dependent on type of material. This only depends on material, right? Material and temperature as well. Depends on material. For copper, it is a certain value. For iron, it is a certain value. For germanium, it is a certain value, right? This is what we call resistivity. So the units of resistivity is what? So this is measured in ohm. This is meters. This is meter squared. So what do you get? Meter and meter squared? 1 over meter, right? So meter goes to this side. Ohm meters, right? Units of resistivity should be ohm meters. Understood? So resistivity is a constant that depends on the material, the type of material, and the temperature. So this is a very fundamental equation, right? So if you think about substances or the material, if you think about a material, let's say like for an example, right? Silver and copper. So these are conductor materials, right? Conductors. These are conductors. So the resistivity of silver and copper, it is around 10 to the power minus 8 in this order, in ohm meters, right? 10 to the power minus 8. Then if you think about germanium and tin, these are semiconductors. So they have a larger resistance. These are conductors. They have a very small resistance, right? Like 10 to the power minus in order of 10 to the power minus 8 ohm meters. Then germanium, tin. These are semiconductors. Then they have around 10 to the power minus 2 or 1. Then we have insulators. Let's say glass is an electric insulator, right? Then you have sulfur. This is sulfur, capital S. So the resistivity of this is around 10 to the power 9, right? So you can see it is 10 to the power 17 times larger resistivity. So you can clearly see why there is a this categorization. So why do we call these conductors, these semiconductors, and these insulators, right? You can clearly see that resistivity is really large, 10 to the power 17 times larger compared to conductors. Got it? So we call these conductors, and these semiconductors, and these insulators. These are called insulators. Take this down, right? Okay, then you need to learn this one, superconductors. Heard that? Superconductors. So any metal can be a superconductor, right? Any metal can be a superconductor at very low temperatures. So what happens is, let's say this is resistivity. So this is temperature in Kelvin, right? When you keep decreasing the temperature, you know that for a metal, resistivity decreases. When temperature decreases, resistivity decreases. But once it comes to a certain value, what happens is resistivity becomes zero. Completely zero, right? Absolutely zero. So this is what we call superconductivity. So for an example, if we take something like aluminium, right? Aluminium, so you know this is a conductor, right? Conducting material. Aluminium becomes a superconductor when the temperature is around 1.1 Kelvin. 1.1 Kelvin is, what's the temperature in centigrades? So it is like 272 centigrades around, right? Around 200 minus 272 centigrades. That is the temperature that aluminium becomes a superconductor. Thing about superconductors is electric resistance of a superconductor is zero. Absolutely zero, right? You just have to know that. You don't need to know why, the reasons why that happens. You just need to know this phenomena. So at really low temperatures, resistance of conductors just becomes zero. That you need to know, right? The uses of this are like magnetic levitation, those stuff, right? Then write the topic equivalent resistance. Equivalent resistance. You are going to get a 1 MCQ from this, definitely. Equivalent resistance. Write this topic equivalent resistance. Then simple A. So mainly there are two types of equivalent systems, right? One type is series. Systems in series. So that is easy. Just R1, R2, R3. So if you have a resistors like this, then the equivalent, let's say capital R. Equivalent means instead of this system, you can replace this system using this without changing anything. That is equivalent, right? So all you have to do is just R is equal to the sum of these resistors, R1, R2, R3. So how do you identify equivalent, system in series? Electric current through each resistor is same. So I is same, right? If electric current through each resistor is same, then we say that kind of a system, that the resistors are in series if it has the same electric current. So that is how we find that. Another one is another type of system is in parallel. In parallel, right? So let's say you have these resistors R1, R2, R3. Okay. So if this has a potential difference V, all the resistors, each of all these resistors have the same potential difference. Here V, 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 right? If the V is the same, delta V, right, is same, we say that such a system is parallel. So each of these resistors are parallel, right? Then you can find the equivalent. Let's say instead of this system, you can replace that using this capital R. So how do we find this capital R? You know this equation, right? 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. So R1, R2, R3 values are given. Just applying that here in this equation, you can find capital R. Okay, take this down. Yes, connected to the YouTube live. Yeah. I send the, it is in the group, right? I send the link. I send the link to the group. You need to participate this live session, right? You are never going to watch recordings, right? I know that. Okay, taken this down. Right. So you can see this equation will it it takes time to solve questions from this equation, right? So when you get an MCQ, you cannot really use this equation, right? So you need to have some shortcut methods in order to find the equivalent when it is parallel. When it is series, you can just add them, it doesn't matter. But when it is parallel, you need to have some shortcut methods there. So that is what I'm going to teach you next, right? Write down note 1. So you should be able to like quickly find the equivalent of a given system. So these notes are to do that, right? So let's say note 1. So let's say you have two resistors R1 and R2. Then they ask you to find the equivalent, capital R. Okay. So what do we do? 1 over, these are the R1, R2. And equivalent is 1 over equivalent, right? You need to find R. So what do you do? R1, R2 denominator. Then at the numerator, you get R1 plus R2. Then flip both sides. So capital R is equal to R1, R2 divided by R1 plus R2. So when you get two resistors in parallel, when you get two resistors, you are not going to use this. It will consume more time, right? So it is easier. All you have to do is what? just multiply those two resistors, then divide by the sum of those two resistors. I'll give you an example. Let's say you get 6 ohm and 8 ohm, right? So you need to find equivalent without using this, but using this one. Find that equivalent. So what do you have to do? Multiply 6 by 8, then divide by 6 plus 8. Understood? So that is easier, right? Rather than substituting here, you can do that in your mind, right? Just multiply 6 by 8, divide by 6 plus 8. Got it? So it is 42 divided by 14. 6 plus 8, 14, right? No, this is 48. So you get 7, 12. 12 divided by 7 ohm. So this is the equivalent. Right? So that is node 1, right? Node 1. Then next one, node 2. Node 2. Let's say you have n number of simple R resistors in series, sorry, in parallel. So there's n number, right? N number of simple R resistors. So you need to find the equivalent resistance. You need to find the equivalent resistance of this system. How do you do that? So if you write the standard equation, 1 over R is equal to 1 over R plus 1 over R plus. So there are n number of 1 over R's. So what can you do? Capital N times 1 over R. So it is R. So if you flip that, capital R is equal to simple R divided by capital N. So this is not, it is very time consuming, right? So what you have to do is, if you have identical resistors, these are identical resistors, right? So what do you have to do? In order to find the equivalent, just multiply that identical resistor value by the number of identical resistors. But the resistor should be identical, right? So for example, let's say you have 3 identical resistors. Each resistor value is 60 ohm. So you need to find the equivalent. So at once, in your mind, you should be able to say the answer here. So what's the equivalent? So one resistor is 60 ohm. Divide that by the number of resistors, 3. 20 ohm. Got it? Okay, so when you get 2 resistors, this is applicable only for 2 resistors, right? So when you get 2 resistors, you can just multiply those values and divide by the sum of those values. So R1, R2 divided by R1 plus R2. Another one is if you have a set of set of identical resistors in parallel, you can just get the one of the identical resistor and divide that by the number of resistors. Okay, so those are the things you need to follow. So you should be able to quickly get the equivalent resistance. If you are going to consume a lot of time, it is not going to work, right? The meaning of that is you don't know electricity. The whole point of learning these steps, I mean these methods, is to reduce the amount of time that you would be using when you're solving a problem, right? So that is the reason there. Okay, I'll give you this example. Just draw this with me. You need to find the equivalent. So there are three resistors in parallel: 20 ohm, 20 ohm, 10 ohm. So you should be able to do this in your head, right? In your mind. So you need to find the equivalent here. These are easy, right? You only have to follow those two rules. I need you to tell me the answer. Yeah. Okay, let's see. So 20, 20, these are parallel, right? And identical. So what do you have? 20, 20 means 20 divided by 2. There are two identical resistors. So this is what you are doing in your head, right? You don't need to write. You can do this in your mind, right? Because you don't have to write in order to divide 20 by 2. So instead of 20 and 20, you can put 10 ohm. Instead of this set, you can get 10 ohm. Then there's another 10 ohm. Again, these two are identical. So what do we do? 10, 10, identical. How many resistors? Two resistors. You can make it 5, right? 10 divided by number of resistors. 10 divided by 2, 5. Okay, next circuit. This is, you can do this in your mind, right? You don't have to write. This is just for the explanation. 20, 20, that is 10, 10, 10, 5. Okay, draw this circuit. 2 ohm, 3 ohm, 6 ohm, 12 ohm. In this circuit, you need to find the equivalent. You need to go for the easiest method, right? You need to be smart about that. You have 2, 3, 6 ohm, 12 ohm. Here there are no identical resistors, right? But you can use that R1, R2 divided by R1 plus R2. So which resistors are you going to use first? I'll use these two first. These two. One is 3 and one is 6 ohm. So you need to get a resistor that gives us a full number, right? Without giving us decimals. So if you choose first 3 and 6, so what's the equivalent of these two? 3 times 6 divided by 3 plus 6. So 18 divided by 9. 2 ohm. Understood? So instead of these two, you can put 2 ohm. Okay. Then we have 2 ohm, 2 ohm. Two identical resistors. So what's the equivalent of these two? 2 ohm divided by number of resistors. 2. So instead of this whole thing, you can make it 1 ohm. Okay. Then what do we have? 1 ohm, 12 ohm. So two resistors in parallel. What do you give? Not identical, right? So 1 times 12, that is the multiplication, then divide by 1 plus 12. So what do you get? 12 divided by 13. So finally you can reduce that whole thing to a one resistor, that is 12 ohm divided by 30. Understood? So that is how you find the equivalent. So you need to be smart about when you are doing those. So you need to get uh, you need to choose the resistors that is easy to do, right? Let's do one more thing. Let's say you have this one 5 ohm, then 15 ohm, then 20, then 30 ohm. Okay, you need to find the equivalent. So all you have to do is just choose that doesn't give you a decimal, right? In the beginning, right? At the end, it doesn't matter with you can get a decimal, but in the beginning, if you get a decimal, then the calculation is going to be complicated, right? So you need to be careful not to take any decimal values while you are simplifying in the beginning, right? Decimals or fractions. So in order for that, you have to choose the resistors. So after this one, right? 4 ohm, 10 ohm, 15 ohm, 20 ohm, 30 ohm, 60 ohm, 40 ohm. Okay, if someone got the answer, send me that. There are two circuits, right? Okay. Okay, first I'll choose these two, right? So you get 25 at the denominator. So when you multiply these two, 5 times 20. 5 times 20 divided by 5 plus 20. So that is 100 divided by 25. You get 4 ohm. So instead of these two, you get 4 ohm. Okay. Then I'll get these two, 15 and 30. What do you get? So this is 35. This is 35. 7, 3, 90 divided by 7. Okay. 90 divided by 7. Then you have 4 ohm and 90 ohm divided by 7. two parallel resistors. Then you have to multiply that and divide by the sum of that. Okay. So 4 multiplied by 90 divided by 7 divide 4 plus 90 divided by 7. Then multiply both numerator and denominator by 7. So 360 divided by 28 plus 90. So it is 360 divided by 118, right? So 59 divided by 90 or something. Then this one is easy. This one is easy. 10 and 15. These are two parallel resistors. So what's the equivalent? 10, 15 divided by 10 plus 15. So it is 150 divided by 25. What do you get? 6, right? So you get 4 ohm here, then 6 ohm here. For this one, 6 ohm. Then you need to find the equivalent here. You have 30 ohm and 60 ohm. How much is it? 30 multiplied by 60. Divide 30 plus 60. So it is 180. I mean 1800. 18 times 100. Divide by 90. 1, 2, 20. So instead of this one, you can get 20 here. 20 ohm. Right? Then there's 20 ohm, 20 ohm. What do you get? 10 ohm. Right? Then you have 10 ohm and 40 ohm. What do you do? 10 times 40. 10 plus 40. So 400 divided by 50. 8, right? Finally, you have a 8 ohm here. Right? 4, 6, 8. 4, 6 means 10. 10 plus 8, 18 ohm, right? So 18 ohm is the equivalent of that whole thing. Okay, then let's try this one. Just draw this with me. So we have 2 ohm, then 1 ohm, 1 ohm, 2 ohm here, 1 ohm here, 1 ohm, 1 ohm, then 3 ohm, AB. So here what you have to find is RAB. What is RAB? Resistance between A and B points. Okay. So when you are doing that, so you need to find the resistance of this whole thing, right? But as you are finding that, you cannot remove this A and B, A or B. You need to keep A and B, but solve the rest of the resistor values. So that's what you have to do. So when you get a question like this, you can think like a current goes from A, right? And it spreads throughout all these branches and leaves from B. the same current. The resistance faced by this current is what we call the equivalent of this whole thing. First, just draw that one. I'll explain how to find resistance between A and B. Actually, there's only like a one way you can get that, right? You can see none of these resistors are series nor parallel, right? This is not series. The current goes from here as well, right? Not the same current. And it is neither parallel, right? None of these are parallel. So what do you have to do? But there's only one at the beginning. These two are the only series resistors. Resistors are series, only these two. So you can simply add these two. Same current flows through this branch, right? 1 ohm, 1 ohm. So you can say instead of that, you can get a 2 ohm. You can replace that branch. So once you get 2 ohm, do you see this 2 ohm? It also is between these same points. So these are parallel and identical. So what do you have to do? 2, you get 1 ohm, right? Instead of this one, you get 1 ohm. Then you have this 1 ohm series. So 2 ohm. 2 ohm. Again, 2 ohm, parallel. 2 divided by 2, 1 ohm. Right? Then 1 ohm. Then there's 1 ohm here. There are 3 1 ohms in series. So you can say 3 ohm. Instead of this whole thing, you can put 3 ohm. Right? Then 3 ohm, those are 2 parallel. And it should be 3 ohm divided by 2, which is 1.5 ohm. See that? That is how you simplify starting from here to here. But throughout the whole thing, we didn't do anything to A and B, right? Because we need to find the equivalent between A and B. Got it? Right. Another thing, let's say note 4. Another thing you need to consider is, let's say you have a resistor 10 to the power 6, right? Then another resistor like 1 ohm. So you have, if you have two resistors like this, and you are asked to find the equivalent between A and B, what do you do? You can think like there's a current going through A, right? And it is divided into this one and this one. But the current through this large resistor is, compared to the current through this resistor, it is negligible, right? So I1, I2, this I1 is almost negligible compared to I2 because it is a very large resistor. Current through that is almost negligible. So there's this rule, if the current through a branch is 0, we can remove this branch. So we can get rid of this branch. Then we can consider that the equivalent of this whole thing is equal to just 1 ohm between A and B. Right? Equivalent is 1 ohm. You can get rid of this 10 to the power 6 ohm, because we can consider that almost all the current only goes through this 1 ohm, not 10 to the power 6 ohm. Got it? Then let's say if you have a system in series 10 to the power 6 ohm and 1 ohm, what should be the equivalent? Equivalent should be 10 to the power 6 plus 1, right? But adding a 1 to such a large value does not make a difference, right? So you can consider this to be a 10 to the power 6. If the system two resistors are in series, equivalent is equal to the larger resistor. That is 10 to the power 6 ohm. Correct? Here you remove the larger resistor. Here you remove the smaller resistor. These are comparatively larger, right? Just take those two. Right. Another one is about Winston bridges, right? Winston bridge. So let's say you have resistors like this, and the values are here 2 ohm, here 4 ohm, 5 ohm, and 10 ohm. So you are asked to find, you can write a Winston bridge, right? So you are asked to find the equivalence between A and B. Equivalence between A and B. So here, let's say this is 14 ohm, right? So without using that Winston bridge principle, you cannot find the equivalence of a resistor system here, because neither of these are series nor parallel, right? There's no resistors that are series or parallel. So in a case like this, always a way to remove one of the resistors, right? So the Winston bridge means what? It should be in this shape and the resistor values should be in ratio. So what's this ratio? 2 divided by 4, right? 2 divided by 4. So it is 1 over 2. Here also it should have the same ratio, 5 divided by 10. So it also is 1 over 2. So these ratio values are the same, right? To this side also it should be same, right? 2 divided by 5. Here what do you get? 4 divided by 10. 4 divided by 10 also is 2 divided by 5, right? So if you have those resistors are in that ratio, we call that a Winston bridge. If it is a Winston bridge, what does it say? Potential at C and potential at D same. Here I'm not going to prove that. If that is in the ratio, this ratio, VC equals VD. If VC and VD potentials are the same, if potentials are the same, there cannot be a potential difference across 14 ohm. Without a potential difference, electric current in this branch is 0, right? So what do we do? If the electric current is 0, you can remove that branch. Okay, so here 2 ohm, here 4 ohm, here you have 5 ohm. Just take this down with me, right? note this down, 10 ohm. Now these two are series. At here, those are not series, right? Without removing that. But now these are series. Then 2 and 6, 2 and 4, then it becomes 6 ohm. Here 5 and 10, it becomes 15 ohm. Now we have two parallel resistors, 6 ohm and 15 ohm. So what do we do? 6, 15, 6 plus 15. So this is 21, right? So we have 7. If you divide 2, 30 divided by 7, right? So this is what we do if you get a Winston bridge, 30 divided by 7. Take that down. And then write the topic symmetry. So this is one of the most important. They always ask. I mean, in most of the time, the MCQ based on symmetry of resistor systems, right? Symmetry. Just draw this with me. 1 ohm here, 1 ohm here, 1 ohm. All the resistors are 1 ohm, right? So each branch has a resistance 1 ohm. So you need to find the equivalence between A and B. So when you get a question like this, you can see none of these resistors are series nor parallel, right? So most of the time you will get a question like this in the exam, right? They are not parallel. Then you need to check the symmetry. Now you can see a symmetry of these circuits. Symmetry means, if you think about along this line both sides, we have the identical thing at here, right? So this part is like the mirror image. So we could not call this vertical symmetry. And also this has a horizontal symmetry as well. If you think about this one, this side of the circuit is same as this side, right? So this has both vertical symmetry and horizontal symmetry. So what do we do? So if you think about vertical symmetry, let's think about vertical symmetry. So if you think about this resistor, right? This resistor and this resistor. So this is like the mirror image of, meaning of that is, if there's a current here, let's say like 1 ampere, this branch also must have the same current, 1 ampere. 1 ampere is for example, right? If this has a 1 ampere, this also should have a 1 ampere. Got it? That's why they are same, right? I mean, mirror image of this resistor. Okay. Okay, let's say this has I1, so this also need to have I1. Then if we consider this resistor, let's say that has I2. This resistor also needs to have I2. Okay. But what happens if there's a current in this branch? That current needs to be added to this one, right? Then you will not have same current in these two branches. So what does it mean? The current through this branch should be 0. Otherwise, we cannot have the same current in these two branches, right? Understood? Only way that can happen is the current through this branch should be 0. If it is 0, we know that you can remove those branches. If the current through that branch is 0, you can remove that branch. Okay, so there's a similar fate for this branch as well, right? So you can remove these two branches. So once you remove that, what do we get? Now these are series. Now it is simple, right? What's the resistance here? 1 ohm, 1 ohm, 2 ohm, 2 ohm, 2 ohm, 2 ohm. There are 4 2 ohm branches. So what's the equivalent? 2 ohm divided by 4. So the equivalent should be 1 over 2, meaning 0.5 ohm. Got it? So once you remove these two branches, then the question gets really easy. Understood? So in the exam, many think that these are the difficult questions. Actually, these are not difficult, right? It doesn't even take a 1 minute. If you clearly see what to do there, right? Okay, take it down. Then draw this circuit. So each of these branch has a 1 ohm. 1 ohm, 1 ohm, 1 ohm. Right? So again, you need to find equivalence between A and B. Equivalence between A and B. Right? So again, this circuit also has both vertical and horizontal symmetry. But you just have to identify mirror resistors, and if they are mirror resistors, those resistors needs to have the same current. So from that you can analyze the circuit. You can decide which ones to remove, right? So when you have to find equivalence between 2 points, you cannot remove those 2 points. You can think that current goes from A and leaves from B, right? If there is a current, the only rule is if the current through a branch is 0, you can remove that branch. So that is the only rule there. but you have to make sure that current through that branch is 0. Okay, right. I'll consider vertical symmetry, this symmetry. So according to that, this resistor and this resistor are, this one and this one are mirror images. So these needs to have the same current, right? If this is I1, this also should be I1. Okay. And if you think about this resistor and this resistor, also mirror images. Let's say I2, this also should be I2. Okay. If that is the case, if there's a current in this branch, if there's a current, we cannot have the same, it's one I2, right? So we won't have the same current in these two branches. So then the only logical thing is you need to remove this branch because the current here should be 0. Then you can remove that branch. Okay. So same fate here, same thing here. This branch also can be removed. Okay. But think about this one, right? So once you remove that, then it is a simple question. And you just have to find the equivalent, then it's easy. Let's say, can you remove these two? This 1 ohm and this 1 ohm? When you think about vertical symmetry, these two are also mirror resistors, right? If there's a current here also should be same. Mirror resistors means the currents are the same, right? But we cannot say that there's the current through this one resistor is 0. We cannot say that, right? So the current through only these two branches are 0. So you remove those two branches. You cannot remove this one, right? Just understand that. Then it is easy. So what do we have? Here we have 2 ohm between A and B. Here also 2 ohm. Here what do we have? 2 ohm, 2 ohm, 1 ohm. Then we have 3 ohm in the middle, right? Then 2 ohm parallel. Then make it a 1 ohm. Then we have 1 ohm and 3 ohm. So what is that? 1, 3 divided by 1 plus 3. So 3 ohm divided by 4, 0.75 ohm. Correct? So that is 0.75 ohm. Then let's do this one. This is somewhat of a special case. Draw this with me. So there's point A. So we have A here and B here. So let's see how to solve that. So when you think about this, we don't have a horizontal symmetry, right? We don't have a horizontal symmetry because we don't have the same image at the other side, horizontal, around the horizontal. But if you think about vertical line, then we have a symmetry. So there's a 2 ohm here. You can separate that 2 ohm like this as 1 ohm and 1 ohm, right? Then these two are mirror resistors. These two are mirror, right? So now you can disjoint this and connect it like this. And you can place a wire to this place, right? You can put a wire like this. Then these two are mirror, right? Then if current here is I1, here also it should be I1. If it is I2 here also it should be I2. Then you cannot have a current through this. It is just a conducting wire. Then we can say that there cannot be a current here. Because if there's a current, it then adds up to this one. Then the current through these two branches won't be the same. It cannot happen, right? So current through here is 0. Then you can remove this branch. Got it? Then it is a simple question. How do you do that? 2 here, 2 to 4, right? Then 2 again 4, right? 2 and 4. So what's the equivalent? 2 and 4. 8 divided by 6, 4 divided by 3. Instead of this one, you can put a 4 divided by 3. You have 2 ohm, 2 ohm 4, 2 ohm, 2 ohm 4, then plus 4 divided by 3. You get 12, 16 divided by 3 ohm. Then you have a 4 ohm. So these are two parallel resistors. Then what can we do? 16 divided by 3 times 4 divided by 16 divided by 3 plus 4. Then multiply both numerator and denominator by 3. What do you get? 16 times 4 divided by 16 plus 12. So this is 32, 64. This is 28. You can divide by 4 both. 24 means 6, right? 7. So 16 ohm divided by 7. Okay. So that is the symmetry. That is how you simplify when you get a question in symmetry. You need to consider the resistors, mirror resistors at both sides. Then you can logically think whether there's a current through a certain branch or not. Then if there's no current through that branch, then you can remove that branch. So that is the rule there. Okay. Right. Then there is so these are the basics concepts in electricity, right? Then we have to discuss about cells. Then there's Kirchhoff laws, efficiency of cells. Then there's a meter bridge, and then there's a potentiometer, right? So those are the concepts there. That remaining part I'll discuss on Sunday, right? Otherwise, it will take more time. The remaining part I'll discuss on Sunday at 7 p.m. Okay. For now, just learn this, and you can again try these questions. And if you have any problem, let me know. Okay. So for today, I'll just wind up here, right? Okay. So see you on Sunday, and good night.